All right, so here we go. How do we simplify radicals with variables and negatives under the square root? So we're going to start off with just basically simplifying radicals. It's stuff that you have done before, all right? Maybe a slightly new method. A lot of it is going to be right from the calculator. It makes it that much easier. So we start off with, in the calculator, we're going to type in menu number factor, so menu 2, 3, and we're going to type in 45 inside the parentheses. That's going to give us a lovely 3 squared. All right, and come on. So 3 squared times 5. So we need to ask ourselves, what do we know the square root of and what do we not? And we have 2 square roots. A square root that I know the square root of and a square root that I don't. So under here, there's the square root that I know everything. Over to the right, there's the square root that's never going to change because I don't know the square root of it. The square root of 3 squared works out to be 3. The square root of 5 stays the same, and that is your answer. So let's do the same thing for the 108. Type it in the calculator, menu number factor, all right, and you end up with 2 to the second, 3 to the third. Okay, from there we need to break it up into a square root we know and a square root we don't know. Well, I do know the square root of 2 squared. The problem is I also know part of the square root of 3 squared, so we got to be careful here. People don't understand that. That's really 3 times 3 times 3, or I could write it as 3 squared times 3. And that's the one I'm more interested in. So 3 to the third is the same as 3 squared times 3. Well, what do I got to do then? Well, I need to break it up. So I have a square root that I know. There's the 3 squared. And then what's left over, I don't know. So there's really multiplication in there. I am going to square root. Well, the square root and the squared actually cancel. So I end up with 2 times 3, square root 3. Now, I don't expect you to ever write that again because I know that you can do 2 times 3 in your head and get 6 radical 3. All right, we're going to skip C and move on down to D. So, typing that in the calculator, you get 5 to the third. So again, we're going to break it up. That 4 in front just means 4 times the square root that we have. So I can break up 5 cubed with 5 squared and 5. I'm looking for the largest number right here, the largest number underneath 3 that I can divide essentially in half or divide by 2. That's what square root is actually doing. So we have it, 5 squared and 5 to the first. So we're going to go ahead and write it out. 4 times 5, the square root and the squared essentially just cancel with each other. And I'm left with 4 times 5, square root 5. Again, I think you can totally do that in your head and just do, oh yeah, that's going to be 4 times 5 right here, so that's going to give me 20. And I'm okay with you jumping right to the answer. You cannot jump, though, from here all the way to here. All right, E, negative 5 root 256. So what am I doing here? Well, I have to break it down. The calculator is going to give me, whoops, got to have the pen, 2 to the 8th. So I'm going to do negative 5, and this time I actually know the square root of all of it, okay? Square root is really a second root, all right? What number multiplied by itself twice? But really what we've been doing every single time here, maybe you didn't notice, is dividing by 2. 2 divided by 2 just becomes 3 to the first. This 2 divided by 2 becomes 2. 3 squared, divide 2 by 2, it's 1. Divide that 2 by 2, you get 1. So technically, all we've really been doing is dividing by this 2 that we have here. So we're going to do that here. We don't need to have a 2 squared inside. We want the largest number that we can possibly divide by 2 underneath the radical every single time. That largest number is 8. So we're going to get negative 5 multiplied by 2 to the 4th, because 8 divided by 2 is 4. And then we do a little bit of multiplication, and that gives us negative 80. Type that right in the calculator. All right, I'm going to skip F, jump on to H and I. I'm trying to do this quick because I know a lot of people have already seen this in the classroom. So why do it really, really, really slow? So we have the 1/2. You do your menu number factor in the calculator with 448, and the calculator gives you 2 to the 6th times 7. So again, you have a radical that you know and a radical that you don't know. You should be seeing a pattern here over and over and over again. Well, that's pretty straightforward. The 2 to the 6th, I can half the power of 6. All right, so it's 1/2 times 2 to the 3rd times the square root of 7. All right, you can jump to the calculator and just type in, obviously, this part. If you type in radical 7, it's going to give you a nasty decimal that no one's going to want to see, including me. So 1/2 times essentially 8 is really 4, and there is your answer. Okay, let's try and write this again. The program stopped working. So 1/2 of 8 is 4. There we go. Now it's really 4 times. You can put a dot there, 4 times square root of 7, or you can just write it as 4 radical 7. All right, 384 works out to be 2 to the 7th times 3 in your calculator. So again, it glitched again. Great. This update was not a good update. So we get 1/3, and then we have to break it up into square roots we know and square roots we don't. Well, obviously I don't know the square root of 2 to the 7th, so I'm going to break that up. The highest power underneath 7 that I can divide by 2 is 6. So that leaves me a 2 to the first over here, and I don't know the square root of 3, so I drop that on the right-hand side. So this is going to give us 1/3 times, we half the 6 to make it a 3, and that becomes square root of 2 times 3 is still 6. So that's going to be 1/3 of 8. 1/3 times 8 is 8/3. Square root 6. All right, we're going to skip J, move on to K, which is really easy. Square root of 9 over square root 16, is really just that, square root of 9 over square root 16, and at this point you should know the square root of 9 is 3 and the square root of 16 is 4. The next question is a little bit more challenging. So the square root of 8, we square root the top, we square root the bottom, just like you saw before. So square root of 8 can be broken down. Obviously square root of 25 is just going to be 5. So I'm going to break it apart. The bottom is just 5. The top is going to be, you type it in the calculator, menu number factor, you're going to get 2 to the third. So I have 2 squared under one radical and 2 under the other. That's going to give me 2 square root 2 all over 5. And there's my final answer. Moving on to the next page. Okay, imaginary numbers. Square root of 1, very, very easy question. The square root of 1 is 1. If you go to your calculator, type in the square root of negative 1, okay, it's going to tell you it is the imaginary unit I. Okay, so imaginary numbers occur when a quadratic equation has no roots in the set of real numbers. So there are no real roots to this bad boy over here. So the square root of negative 1, we're just going to go with is I for now. We'll talk about a little bit more where it comes from when we do a little bit more with graphing. So the square root of negative 36 can be broken up, again, into 2 things that we actually know, a little bit different than the previous page, but we have square root of negative 1, which we know, and the square root of 36. So basically, you're just pulling that negative out and saying, hey, I know that negative 1 times 36 would make negative 36. And from there, we know the square root of negative 1. That's just right over here, I. Kind of a joke for now. And the square root of 36 is 6. But no one really writes I6. You've never seen X6 before, right? So we're going to change this around and rewrite it as 6I. Typically, we put the imaginary, the I, after the number. Let's try question 2, and then I'll have you guys do C and D. So in question B, we have 2 square root negative 45. So we're going to break it up. 2. All right, when we do menu number factor for this one, we don't just happen to know the square root of 45 like we did 36. That was nice. So when you do menu number factor, you get 3 squared times 5. All right, so we know the square root of negative 1. Let me erase that. Come on. And I know the square root of 3 squared, square root 5. So this becomes 2. Square root of negative 1 is I. The square root of 3 squared is times 3. And then we have square root 5. We are allowed to multiply the 3 with the 2. So we end up with 6 times I. So 6I square root 5. So basically the same thing as what we just did in the previous page. There really isn't much added to it. You just need to make sure that you add the square root of negative 1 becomes an I. What we don't do is we don't ever put the I over here, because if somebody extends this square root symbol over, then it looks like you have 5I underneath. Technically it isn't wrong having the I over here, but it just looks like it could be under the radical and is generally a bad idea. I'm going to erase it now, hopefully. All right. Why don't you go ahead and pause the video right now. I'll do the menu number factor for D for you, and then you can pause the video. I apologize. So this is 2 to the third, and obviously you should know the square root of 49. So go ahead, break the 2 of them up. I'll put the answers in just a second. Pause it now. Okay, so you know the square root of 49 is 7, square root of negative 1 is I. There we go with 7i. And last part, 2 to the third is broken up with 2 squared and 2. Square root of negative 1 again is going to be I. I don't expect to see all this work. I'm just showing this here for people that need to see it. So square root of negative 1 is the I. The square root of 2 squared is 2. 3 times 2 gives us 6i. I'm okay if you go look at this step and say, yep, that's going to be 6i radical 2 and move on. That is a-okay. All right, so simplifying radicals with variables is where it gets a little bit more challenging, I guess, but not really a whole lot. It's pretty much the same that we've been doing on the previous page and this page. So the square root of x squared, the square root of x to the 6th, x to the 5th, x to the 7th can all be found pretty easily. And you kind of already have the idea from what we've been doing. So anything squared, square rooted, they just kind of cancel, and that works out to give us x. And we've kind of seen on the previous page that when we have a power, okay, that's not 2, we take and simply divide that by 2. So that's not so bad. We're just going to take this and say, okay, that's x to the 3rd. Okay? But what happens when we have an odd number? Well, just like we did with the numbers, all right, we're going to break it up in terms of a square root we know and a square root we don't. So I can square root x to the 4th, but I can't square root x. So I break it up with exponents of 4 and 1, and hopefully you know that 4 and 1 makes the 5 there. So this is going to become x squared, square root of x. Same with the x to the 7th. We're going to break that up. So we ask ourselves, what is the largest number underneath 7 that I can divide by 2? And that number is going to be x to the 6th. So we have a square root of x to the 6th, and then an x to the 1st, which we don't really need to write as x to the 1st. We half the 6 and get 3 times the square root of x. So, for an even number, anytime we had an even number like the 2 or the 6, we just simply took and did the even number divided by 2. So your answer is always going to be very easy. It's x to the even number over 2. And there's no radical, and life is good, and it's just a joke. When there's an odd number, though, you have to do x to the power of the odd number minus 1. So the odd number minus 1 over 2, because when you subtract 1, seems a little bit weird, but when you subtract 1, right, from any odd number like 7 or 5, it gives you a number that is divisible by 2. But there's still something left that we have to have, and it's got to be multiplied by, and in both problems we had it. If you notice, we had a square root of x and a square root of x. So we should have that for both of them. Okay? And that's how we'll break down every odd number. Not that you need to memorize that. You're just looking for the largest number underneath 5 or 7 or whatever the odd number is, and then divide by 2. So let's try some problems. Damn it. Example 3. So 50b to the 3rd. I need to break it up into numbers that I know the square root of and numbers that I don't. So the many number factor from the calculator, menu 23, will give us 5 squared times 2. So again, we have a square root of 5 squared that goes over here, square root of 2 that goes over there. The b cubed, I have to break it up, so I have a b squared over here and a b over there. Everything on the left-hand side, underneath this square root, I can divide by 2, so I do. That gives me 5b. Square root of 2b. All right, so we're going to skip 2 and 3 and move on to question 4 because, well, if you can do question 4, you can do pretty much any question they give you. So you're going to go to your calculator real quick first and type in the many number factor and get 125, and you're going to see that it says it is 5 cubed. And now we're just going to break everything apart. I have a square root of everything I know and a square root of whatever is left over. So the first part would be the 5. I can break that up with 5 squared because that exponent of 2 can be divided by 2. And then what's left over is 5 to the 1st. You don't have to write the 1, but you can. The 8 to the 4th. I can divide 4 by 2, so I'm going to put that right there and call it good. B to the 7th. I cannot divide 7 by 2, but I can the 6. That leaves me with 1 extra b over here. For the c to the 9th, again, I'm going to go a little bit less than that. one less actually, c to the 8th, and then I have a c to the 1st. d to the 12th can all be put underneath the 1. e to the 14th leaves me with an e to the 1. And then f to the 20th, I can divide all by 2. The g, nothing going on there, so I just put the g to the 1st here. I can't divide that by 2, and it's just left over. Sometimes you can't do anything with it, and you just have to write it off to the right-hand side. So now we're going to take and divide every single one of the exponents by 2. Remember, that's because there's really a 2 out front here, so we're just dividing all of these by 2. That's what happens with the square root and the squared canceling. You're really dividing by 2. So go through and divide them all by 2. Alright, so it's going to give me 5. Let me change this color here. So 5, and then a squared, b to the 3rd, c to the 4th, d to the 6th, e to the 7th, and f to the 10th, and then all multiplied by the square root of 5b, c, e, g. Notice I didn't write the power of 1. You really don't need to. That's that. So as you look below, go ahead and give these practice problems down here a shot. Practice on your own. You'll see that the answers are right over here. So give it a try, and then check your answers. Don't forget to write your summary when you're done, and we'll go from there.